Welcome to the June meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in Houston's West Chase District. You can check us out for meeting notifications at HDNUG.org, on Facebook, or on LinkedIn. And now a word from our sponsor, TEKsystems. TEKsystems recruiters utilize a consultant-first approach to their sourcing efforts. They make sure to ask probing questions regarding what is important to you as it relates to technical skills, career aspirations, and overall interest in types of jobs. This ensures the best match for both the consultant and the customer, leading to a successful engagement for all parties.
All right. As a good architect, I have my own PowerPoint clicker with laser, right? To give you some of my architectural credentials, I put together this PowerPoint. Okay? Got it. So, this is me. Just about the only things you actually need to know about me. Now let's talk about the perception for architects. Anybody ever worked with a great architect? A fantastic one. 4 hands in the entire room. Great to hear. By the way, let me qualify that. That isn't yourself. No hands in the room. Got it. All right. So what's
22 years still on that one?
So what's the perception, right? Some of the cores, some of the architects I've worked with have been really intelligent. They've saved me from making stupid mistakes because they fell into that hole before and they knew how to avoid it. They're deliberate, they're connected sometimes. But what's the other piece? The ivory tower architects that are disconnected, hands off, right? Or out of date. Architect meant you stopped having usable skills 20 years ago? No? Yes. And so the problem with this is that we have, as an industry, turned architecture into a career progression path for purely technical people. It is, however, not a great skill set match for somebody who has simply been writing software for 15 years. Architecture requires a lot more. And so we're going to talk about the evolution of architecture from its base level of when you stop worrying about just getting the code functional to its eventual evolution to enterprise architecture. Because that is not a short path. So what are some of the types of patterns we use in software? I'm actually asking. I'll stand here in awkward silence. It's fine.
MVC.
Right? We use MVC. We use display patterns. MVC, MVVM, MVP.
Creationary patterns.
We use creationary patterns. We use structural patterns. We use behavioral patterns. Anybody that's read The Gang of Four is like, hey, he hit all 3 types. We use design patterns, right? We use interaction patterns, we use messaging patterns, we use asynchronous patterns. We use solution design patterns. We use what?
Compound patterns.
We use compound patterns, absolutely. So
We use anti-patterns.
we use anti-patterns. What's the definition of an anti-pattern? A pattern that we don't like. I hear that one often. A pattern that's bad. Here's the thing, patterns aren't bad. They're not. If somebody cut a door into the second story of a house, would you blame the door? Right? Like in the outside wall of a house, there's just a door on the second story. No platform to somebody to walk out. Just a door. Right? The pattern's not the problem. It's you used it in the wrong place. You used it for the wrong reasons. Anti-patterns are the patterns that are so prevalently misused that we avoid them on spec.
I had a friend called arrow.
The arrow pattern. Absolutely. So here's the thing. Absolutely. So if I'm looking at, let's say, a deep nested graph of an acyclic, or a deep nested acyclic graph, if I unwind a stack trace for logging, it will look exactly like the arrow anti-pattern. However, I need to do that level of coding to triage deep acyclic graph problems. Now, how many people in here have actually worked on a deep acyclic graph? 2. So is the arrow anti-pattern relevant for most people? Absolutely. Is it a quick gauge of, is this code quality? Yes. Is it infallible? No. And we're going to talk about the evolution of awareness when it comes to architecture, because just like anything else, right? Anybody ever heard of CMMI? Yes? Anybody know what CMMI is? There it is. It talks about the ability to recognize when things work, when patterns should be applied, when templates should be extracted, and then when you should break your own rules. CMMI Level 5 is about breaking rules in the right way, at the right time, for the right reasons. Shu-Ha Ri. How many folks have heard that piece of thing in like Agile training, right? They talk about Shu being obedience, where you do the thing you were told to because you were told to. Ha being where you're starting to understand the whys and the principles and the values that drive behind something. And then Ri is where you've realized that there is an additional set of things that nobody has done before, that you haven't learned from people, but you have combined sets of knowledge into new patterns that you can then teach other people. We jump straight to Ri often. How many times have you heard a team that's like, yeah, we've been doing Scrum for 6 months, we threw out retrospectives because they are horrible. It's like, you haven't been doing Scrum because you have obviously jumped straight to modifying a system versus understanding a system. By the way, this comes out often for consultants and contractors, and you know how it comes out? As soon as I say this, everybody in the room is going to groan and go, yes, I've heard that. You ready? Oh, that's crap. We got to rewrite it. How long in a system do you have to spend before you know if it actually needs rewritten? Days? Hours? Minutes? Or months?
It depends.
Depends on the system.
Depends on the system, but if your answer is less than months, I immediately question your judgment.
I've seen some systems that you look at it and 2 minutes later you're like, yeah, this needs to be rewritten from the ground up.
A couple of this isn't working anymore. This is a fundamental part that is required for the working of the system, and it is a certain amount of skills.
Sure. Maybe. How many folks have been on a big rewrite project? Okay, keep your hands up. How many of those projects went incredibly well, succeeded in all the business values, on time and on schedule? I didn't have time constraints, right? On time and on schedule, I should also add on budget. So here's the thing. I agree that sometimes rewriting sections of a code base is a good idea. I don't, however, agree that rewriting an application wholesale because you don't agree with the implementation in several places is a good idea. And oftentimes, evolution is better than revolution when it comes to software.
What is the data technology? Like, let's say the company's doing this,
Dated technologies. How do you deal with them? Absolutely. It's a problem. Now, you could absolutely insulate it with an anti-corruption layer, aka an integration layer that wraps the old technology while you incrementally develop the technology in modern pieces that takes that over behind an interface pattern. It's actually one of the standard application integration patterns. It's one that we don't talk about often because, oh, we'll just rewrite it and it'll work just like the old system. Yeah, except it won't. Because when somebody says rewrite the old system out of the dated technology, what they mean is rewrite the pieces I like, get rid of the pieces I dislike, and make it more modern so it can do different things. Which means you'll never get the feature parity. You'll just get the body close enough to complete, lug it across the finish line, and declare victory. Right? And so when we start talking about this, there are almost no unnuanced answers. Every answer is going to be it depends. And so for the next few hours, I may shorten it because Jay's going to throw me out at some point. For the next 70 minutes, we're going to be talking about those nuanced decisions and how they evolve. Technical design. What are the important steps in technical design? What is technical design? So technical design is the first step beyond I need to get it working. If I asked a junior developer to go hang a painting, and they would assume I've given them all the tools to do it, and on their desk, tape and staples. And so they hang a painting, tape over the corners, they staple the tape to the wall, and it's over there. Is that a good way to hang a painting? Why not?
Structure.
It's got structural issues, it's got functional issues, it's going to fail at some point. But does it accomplish the goal? It does. It doesn't accomplish it well, it doesn't accomplish all the uncommunicated pieces of it, and it doesn't prepare for the future. But it does accomplish the goal. So when you get into technical design, it is the first step of awareness towards architecture, in which accomplishing the goal is no longer the measure of success. How many developers have you ever met where accomplishing the goal was their measure of success? Anybody ever met that kind of developer? I have. I oftentimes try and get them fired. If accomplishing the goal, as written, as communicated, is your only measure of success, we have a problem. Because how many times has a business person asked you to build something that they don't want because they couldn't communicate what they do need? Right? Or how many times have you heard the following sentence when it comes to requirements? Oh, that will never change. And then inevitably what happens? It changes. Now, I'm not saying we code for every corner case. What I am saying is that simply doing what you're told, we're not data entry clerks. And when you hit that realization, which some developers never do, when you hit that realization, you've entered into the first step towards architect, which is the awareness that solving the median problem is not enough. I have to start looking at the other pieces. Now, we have a lot of tools in this area, and they're terms you've probably heard. What are some technical design practices that you've heard of? Make it scalable. Okay? That might actually trend into a whole bunch of other things. Anybody ever heard the phrase TDD? TDD is a technical design tool. It has nothing to do with the test. It's about changing the way you write code to solve future problems, make it more modular, more componentized, making sure that logically you've gotten to the right steps. It's a technical design tool. What about the solid principles? Incredibly small scope. We're talking about single responsibility for a class and a method. We're talking about open to extension but closed to modification to a class. List-off substitution is class-based. Interface segregation is class and interface-based. Dependency inversion is class-based. None of them are bigger than any single construct that is compilable. Right? It's the smallest compilable unit. It's technical design. If I build an application using TDD and solid, will it be built well? Maybe. Will the classes be built well? Yes. And that's where we get into the next step. Solution design. Because technical design is not enough. Now, what's it take to make that jump? To go from technical design to solution design. There are a ton of developers that never make that jump, by the way. Good technical individual contributors that often become team leads that can't see glaring problems staring them in the face. Domain-driven design? Absolutely. It's a pattern for solving solution. But what's the impetus? What's the thing that typically pushes somebody from technical design into solutions design?
Well, I mean, solution design would be more understanding the domain, understanding the problem, being able to think around.
What do you have to have a solution?
You have to understand the problem.
You have to have a problem that you understand to be able to design a solution to it. As a technical person, I simply need code. I can design code well, and I'm doing technical design. But it's the moment where you realize that I'm writing all the code in the world, but we're still failing. I need to understand the problem. You've now hit that bar of awareness. By the way, there's tons of developers who never hit that bar. We're talking about a log problem. Yes, sir? No. Not in evolution of awareness. Now, every step you take is going to change the way you write software, right? When you realize that you need to do solutions design, it's going to change your process. And the first step in the new process is going to be understanding the problem. And then the second step is going to be designing a new solution. The third step is going to be right back to your technical design to build the solution well. These are additive, and some of them often are multiplicative. But every step changes drastically how you approach this, right? So I'm going to extrapolate beyond the let's go hang up a painting. What if I asked a contractor, a general contractor in real estate, to build me a 2-story house? Are they going to understand it? They're going to be able to accomplish it if all they've ever built is 1-story houses.
Still don't know your needs.
Right? If I hand them, here's the architect's drawings of exactly what I want for my 2-story house, and all they've ever built is 1-story houses, will they be able to do it?
Yes. They'll struggle with this too. Because they have these diagrams.
They'll be able to succeed closer to it, but they'll still struggle with the stairway, right? Or they might struggle with, all right, how deep do the moorings in the foundation have to be? What do I need to do for higher load bearing on the ground floor to make sure that the subfloor on the second floor doesn't rattle and shake? I will get a less quality solution, but they may be able to get there. Now, here's the fun part. What if I take those same architect drawings and I go, I'm going to build a 1-story house, and I have an architect plan it all out, and I take it to a subcontractor or a general contractor that builds 2-story houses all the time. And I ask them to build my 1-story house. Are they going to be able to do it? Absolutely.
You have a great attic, too.
There it is. I'll get over delivery on my 1-story house because the patterns they use to prepare 2-story houses will get applied. And I will actually get more technical scope creep because they're used to their patterns. Solution design requires that you viciously question your own design assumptions. It requires that you not swing a golden hammer every time. Anybody ever met the pattern in hunt of a solution kind of architect where everything is messaging systems, or everything is database and stored products, or everything is MVC, or everything is strategy patterns, right? Because it's like going to an oncologist because you have a sore throat. You know what they're going to tell you? You may have throat cancer. Because that's all they look for. A good person who's hit that awareness level for solution design, when they hear hoofs behind them, they don't think zebras, right? Until they turn around and go, that's a funny looking horse. It has stripes, and I'm in Africa. It is the ability to viciously question your own principles. Now, how do you know when it's done wrong? When solution design is way off base, how do you know? It doesn't respond to change well? That's a really great indicator.
It doesn't give you the right answer.
It doesn't give you the right answer. What do you mean by the right answer? How do I tell if a design is wrong? Now, typically, you can't tell the design is wrong until after the application is significantly invested and built. So how do I know if the design was wrong?
It doesn't sell.
It's overly complicated?
Depending upon the problem is, of course, the solution design for applications like Facebook or Twitter, which solves one problem, is different than the application design for an enterprise application. So that would make a difference.
Mm-hmm.
I think it's about understanding the implications of using a pattern in order to meet design objectives.
Yep. So solution design can be summed up in kind of one overarching sentence. How do I allow for A and B in the future while solving problem X today? If A and B never come true, or aren't reasonable to expect to come true, my design's wrong. If A and B are really, really, really difficult later, my design was wrong. And so when I step into applications, I'm oftentimes fighting solution design problems because things that should be simple are really, really difficult. And things that should be difficult have been hyper-focused to become too easy. It's the really great attic in a one-story house, right? The overbuild of structural walls to make sure to support extra weight in my one-story house that's never going to exist.
I was thinking of the door on the second floor exterior wall.
Because they might someday want a balcony, right? It's those kinds of things. Anybody ever worked in an application where, well, you know, hey, I'm looking at this thing, and you guys have a templating scaffold system to build out for Oracle and SQL, but we've never run this application on anything but SQL Server. Why is this Oracle chunk of the code base there? The someday maybes, right? And we run into architectural someday maybes all the time, right? The person who puts an interface and an abstraction layer on an interface and an abstraction layer on an interface and an abstraction layer, and you've got to get through 8 layers before you find functional code. I'll give you an example of yes. So I'm going to give you an example from code I have personally worked in. I didn't develop it. I worked on a system that quite literally had no classes in its domain. It used the Castle Windsor dictionary adapter and interfaces with attributes to code init classes on the fly so that if interfaces coming in differed, it could auto-generate classes that represented the domain. To try and solve multiple inheritance in C#. So now here's the worst part. Solution design mistakes oftentimes are found after it works. That software worked and worked well. But simple things were crazy hard. Right? Adding a new field was 2 sprints of work. Right? How many times have you gone back to the business and gone, yeah, that simple change, way more complicated. It's the here be dragons moment when you step into that segment of code and you feel uncomfortable immediately. And you're worried you're going to break everything by changing the one thing because there's a T4 template system that will regenerate half the application when you make that one change. That's solution design gone awry. Now, how many times have you been in a situation like that? Who's been in a situation where you feel the solution design was off? Right? How many of you could point to exactly the mistake that was made? Like, the design was this, it should have been this. That's the hard part, right? It's pretty easy in your gut, once you've gotten to the point of looking at those problems, to go, this feels funny. Like, this is like shorts in December weird, right? Well, other places than Houston.
I was going to say, in Houston, that's kind of normal.
Right? It's like there's snow on the ground, and, I'm deciding that, hey, running outside and making snow angels with no clothes on is a good idea. Like, it's those kind of things, like, this just seems wrong, right? It's like talking about comic books and only talking about the DC universe. Something's missing, right? The good ones. Sorry, couldn't resist. So then, how do you address this? How do you structure it when you know something's wrong? I typically look for extraneous patterns and missing patterns. What's the pattern that seems to serve no valid purpose? The abstraction on an abstraction. And I start asking questions. Because it might actually have a purpose, and I'm just not deep into this system enough to know. Which, by the way, I use this specific example about the no domain classes thing as this example because it had a purpose. And there quite literally was no other way to solve that problem. It was a problem specific to that domain. And using C#, which was a hardline architectural requirement from not our control, that was the only way to solve it. Right? Sometimes there are reasons. We won't call them good or valid reasons. We'll call them reasons. Right? How many people in here go to work and you're like, you know what? I'm going to make dumb decisions today. And everybody's going to have to live with them because I hate people. Thank you, Jay. That was Jay Sawyer raising his hand from Hitachi Consulting. and Mark Reynolds. So
From Southwest Energy.
yeah. So here's the thing. Very, very.
And he teaches, too.
And he teaches. So here's the thing. Very few, if any of us, and I know you guys are being facetious, go intentionally looking to make systems overly complex. It's not resume-driven development. We're not looking to try and drive things in simply because we think it'd be nifty, even though we know it's wrong. It is typically because we have misunderstood a requirement as far more important than it is, or far less important than it is. We have misunderstood something in the problem space. How do solution designs deal with this? So if you're going to try and structure a solution design, how do you avoid falling into this trap? How do you avoid it? Like, if you know there's a trap here, how do you avoid it? Yes, sir.
I would say that part of what you've got to have is when your current scope is and with the different scopes out here, you always put it to the test of which one can go which one.
Absolutely. Constantly reevaluate, looking at future functionality and scope against where you're at and where the architecture will be.
But how does it go with a solid design? Because basically, a solid design, you do what you do. You don't really try to anticipate something. I mean, you try to anticipate, but you don't design for the future requirement.
TDD and solid would tell you don't design for future requirements. But keep in mind, that's here, right? When I start talking about a solution design, if I've got an application that we're designing a solution for, and they need to be massive scale, they need to be globally geo-redundant, and they need to have no single point of failure so that they have 4 nines of uptime, right? Are you going to recommend a thick client MVC or WPF app that talks to WCF servers on-prem? Or are you going to recommend a web application running in a cloud provider of some kind, right? It has nothing to do with the solid principles of technical design or designing for the future. It is simply saying, what's the problem space, and how do I craft a solution that will allow for A and B in the future while solving X right now, right? And so that's that question of elevating beyond technical design. The only trick that I have found that works here, and it's the only one, make as few decisions as possible. And by make as few decisions as possible, I'm also including the decisions you make by default.
You mean defer decisions?
I mean, unless it is critical to choose right now for future A and B, don't. Because 6 months from now, or 2 months from now, or 4 days from now, I'm going to know more about the problem space than I do today. I'm going to have more data about what actual usage looks like than today. And so unless it is critical to make the call today, don't. Right?
That's got to be keeping with a just-in-time principle.
Absolutely. Now, when I say it's critical to make that decision, there are some decisions you can't start without making. Right? Web versus thick client. Cloud versus on-prem. Now, here's the fun one. Cloud versus on-prem. Do we have to stay where we start? No.
Sometimes you have to.
Sometimes you may, but technologically, are we required to stay where we start? Cloud versus on-prem. Not if we do it right. And so when I say make as few decisions as possible, build the application so it doesn't care. Don't use any cloud-specific tools. Don't use any on-prem specific tools. Chart the middle line until you have to make a decision. Right? I can run a SQL server on every cloud provider on earth at this point, basically. Right? Or I can run Oracle on half of them. Right? I can run Linux and Windows on either of them. I don't have to make the on-prem or cloud decision up front the way most people would tell you you have to. You don't.
Now, the terminal server in the cloud, an on-prem application or a cloud application?
We're going to skip that one for now. And so it's making as few decisions as possible, which takes a lot more work, by the way. takes a lot more work because you have to consciously choose to build things that make very few decisions. It is much easier to make all the decisions and live with the consequences.
I would extend what you're saying, and this is more of a problem for the younger, more junior developer, but it's still, I've seen it with the more senior. You're almost with solution with the problem. You start listening to what the problem is, and before the guy gets done with the first paragraph, you have a solution that you're building.
But it's always like this.
So here's the thing.
And it's hard to deal with, but if you just sit and let him talk for an hour or two, just shut up and let him talk.
So here's the thing. I'm gonna expand on what you're saying because yes, and you've hit on my second point. This is the level of awareness by which your technical ability is no longer the primary driving factor. Your soft skills are the primary driving factor. Do I have the ability to actively listen, not just wait to speak, not just wait to respond, but actively listen to the business as they describe the problem and the future? Actively listen to the other architects and the ideas that are going out, and be able to parse them, analyze them, and honestly consider them. That's the differentiator. You want to talk about why some people make it to, tech lead but not to architect? That's the differentiator. I have met some tech leads that could easily, on technology, blow me out of the water, but they were unwilling to listen. They knew best, they had seen it all, they had heard it all, and they wouldn't consider other opinions. This is where soft skills start working their way into that structure. And it gets even more when you start talking about systems design. Now, we talk about solution design. How many people are utterly lost at what I mean by system design? Awesome. So, by systems design, this is multiple solutions working in concert to solve big, hairy problems. It's the website that shows your products to your customers, the product management site internally that allows your folks to put them up, update pricing, those kind of things, the marketing piece that allows marketing to put in campaigns and structures and rules around it. It's the inventory management piece that allows you to notify the other pieces of the application. It's all of those working in concert to solve one big, hairy problem, which is delivering hard-to-sell products to customers correctly and on time for the right price. It's the inventory management system and the operations system talking to the accounting, invoice, and distribution system that allows the delivery of oil across a massive set of assets inside the United States. It's the delivery and logistics system that keeps cars, products, and shipments moving between here and China across n number of providers. It's tax software that allows you to go in and plug in all your details. And each module evaluating your audit risk, evaluating whether you meet the median pieces, recommending different adjustments. Keep in mind those are all written as pieces. It's a system, not a single solution. What do you have to start thinking about when you think about system design?
What comes to mind is solutions. The whole thing. You have to understand. You have to understand the domain space, the problem space, in order to craft solutions that utilize systems to solve those problems.
Yep. So here's the fun part about this evolution towards that kind of elusive enterprise architect. You have to know very well the previous step. And you have to be willing to give up any steps that came before that. Can you be effective at designing a system of interconnected solutions if you're caught up in exactly which patterns they're using in structural, behavioral, and creational patterns at the tech design level? Huh? Right? If I'm caught up in exactly how every Lego gets built, can I build the Millennium Falcon? Probably not. right? So you have to start decoupling yourself from the problem spaces that are more than one layer away, because you're going to start thinking about a higher level of constructs. You've got to be able to let that piece go. Now, here's the fun part. You still have to have understood it. Because to be a really good solution designer, you had to be a really good technical designer. To be a really good systems designer, you had to be a really good solution designer. And so it's evolutionary, but you have to start letting other people play into that space. Because if you're trying to understand at every level, every decision made, you hit a bandwidth saturation problem. Now, how many of us find it easy to give up things we're good at and we get praised for? Right? It's hard. Human nature is to seek those accolades, seek that praise. And so, as we evolve, it becomes harder and harder to step back. Anybody ever worked with somebody that's a senior architect, but they still do every code review? I have worked with those folks. They're crammed into meetings. They're still trying to do code reviews. They're still trying to do everything. They haven't been able to let go of the bottom layer, which is holding them back from moving up the stack. Now, when we get into systems design, are all systems created equal? I sum this one up. Not every outhouse needs marble columns. So when we talk about systems, is the system that runs the DMV to renew your driver's license as critical as the system that runs the heart and lung machine in the neonatal NICU? Why not?
Life's on the line.
The problem space and the stakes are different. I not only need to understand at a system level the problem space of each solution, but I need to understand the criticality of failure in each of those pieces, the likelihood of failure, the size and scope of the problem. If I've got a solution that's going to handle 1.5 billion records a month, right? I'm probably going to make architectural sacrifices around its edges to other systems or other solutions to make sure that it can optimize to handle that latency or that throughput without giving up tons of latency. I'm going to start trading problems, solution to solution, to solve bigger problems. Now imagine that you're building that web e-commerce system. And you've got a hard problem. You're trying to sell something that, if you had put it into like a product catalog, would be over 7 trillion products. And no system on earth can do that reasonably for the cost benefit. And so you're trying to solve that problem. And it turns out you can solve it by making one area of the code base really crappy. But you can solve it. Do you make that trade?
Define the crappy.
Right?
Define the crappy.
It will be incredibly hard to maintain, hard to understand, and it will be the area of the code that you spend the vast majority of your time never touching after it's solved. Absolutely, it's worth it, right? What if it is, I have 2 people that can write that piece of the software, and even though it's going to slow down every other team, we're pulling our best 2 people to solve the one big nasty problem.
You just described using regex.
I love regex.
So I used to say there are 3 R's in bad programming: recursion, reflection, and regular expressions. And then they added dynamic, which I'm choosing at this moment to have start with an R. And so then now there are 4 R's of bad programming. Here's the thing, they all have reasons to be used, and I have written applications that used all 4 in the same lines of code. But how many people, I mean, we talked about the directed acyclic graph traversal earlier. How many people truly have solved a problem in that space? Or an in-depth binary tree traversal where you're generating code at every layer? Very few people ever have to tackle those problems. Very few people ever have to solve those problems. And very few developers can. And so when you're talking about systems design, it is no longer just a technological problem. It is a business meets resources, meets timelines, meets skill sets. And you're trying to optimize all of those things and trading problems to get the problem centralized to the teams that can solve them at the level and timeline that they can be solved. That's not an easy problem space. It requires coordinating with multiple people on hard problems and building consensus. And so, if you were going to dive into a system design for one of those two problem spaces, by the way, we're going to shift into a tool that most of us have used, Entity Framework. Is Entity Framework a solution or a system? It seems very systemy. It's a solution. Maybe. Now, it has an object state manager, right, that interacts with an object relational mapper, that interacts with a data connection provider, that interacts with a SQL parser, that interacts with a queryable provider. There are 5 significant chunks to that system that each had to be well-built solutions. Now, at the same time EF came out, there was another team at Microsoft building Link to SQL, solving the same problem. Which one survived? Entity Framework. Why did it survive?
Because it didn't suck.
Pardon?
It didn't suck.
So, by the way, Link to SQL had more features, was faster, and had a bigger user base when it died.
Where was the profit?
Huh?
Where was the profit?
So, interestingly enough, neither one of them generated profit. So here's the thing. They missed a solution on the Link to SQL team. The provider that did translation was bound to SQL Server. Link to SQL was bound to a single technology stack, which drastically reduced its usability, which meant it wasn't going to get massive adoption outside the Microsoft stack, pure Microsoft stack companies. But if I could make one change and introduce a provider that allowed for any relational database under the covers to be supported, I could grossly increase my supportable code base. The users, potential users for it, would be massively bigger. The system missed a big requirement because they weren't focused on it, and it killed the product. Whereas EF, which was a worse product when that decision was made, didn't miss that requirement in the system. And to this day, that requirement lives. Now here's the funny part. They've rewritten EF since then because they realized, wow, we over-adjusted to this one workflow that isn't the biggest part of our user base. And getting off of that over-optimization for a single workflow required them to rewrite 3 of the 5 core solutions. You know which ones they didn't tackle? The state manager and the provider. They rewrote the SQL translator. They rewrote the queryable provider. But they didn't touch 2 of the 5. Right? The people in that space and coordinating across the N number of teams that actually had to do all that work. I mean, you're talking about massive coordination, both technologically and based on people. And that's really where this differentiates. So, how many of us work on systems versus solutions? Right? What's the applications you're working on? Are they big enterprise applications or are they big enterprise systems? Right? Some of us are working on really big applications. It's a single application, does a lot of stuff. Some of us are working on big systems. It's several big applications doing a lot of stuff, and they all have to do it in concert. That differentiation changes drastically the way you have to approach architecture. Why? Because at some point, I'm going to need to make updates to one of those big things and not break all the other things. Versus at some point, I'm just going to patch the update to the application and it will have some big new chunk. Right? You start seeing these things like, are you building the monolith versus the microservices? Do you have microservices that are stacked up to look like a monolith? Right? And so that's where you start seeing this argument, monolith versus microservices. It's all in the system design space. Now, there's a great book called The Enterprise Integration Patterns that talks about system design and enterprise application architecture. So we're going to get into enterprise application architecture. Huh? Oh, do I? Oh, okay. Yes. I missed an O. It's terrible. You guys can leave now. It's fine. So when I say enterprise application architecture, I am not, however, talking about enterprise architecture. That's the next step. I'm talking about enterprise application architecture that if you've worked at Big Oil or finance or something like that, these are the 5-year projects that seem to take 7 that start with 40 people and seem to have 180 on them at the end of it. Right? Anybody heard the term BP Energize? Yeah? It was a massive application rewrite for like 50-something applications that got rebuilt into one big platform. Right? Anybody heard of the Enterprise Products Evolve product? Yeah?
No idea what you're talking about.
Exactly. Everybody in this market has heard about that one. Right? We all hear about these things, right? You hear about the DOL work in the finance space, if you're in the finance space. The Department of Labor adjusted some rules. Every financial company out there had to go rewrite chunks of systems. Enterprise application architecture is typically 2 things. 1, highly complex, and 2, tied directly to revenue of large companies. So it's not exactly a stress-free working environment. Now, I got to work with some great folks, like Devlin back there. Wave, Devlin. Hi. There you go. Working on a massive application like this. And I've gotten to work Six Flags with their season pass processing system across the U.S., and I've gotten to work with Goldman's Commodity Group and a bunch of others. And what I have found is those projects live and breathe on the core team of folks that are trying to wrangle the decisions that will either kill you or not, and trying to make sure that they don't get unmade. Right? Folks that can design good systems are far more common than the folks that can design good enterprise applications. What are some enterprise application patterns that you might have heard of? Enterprise design patterns. Orchestration. I have a list. I'm going to have to switch modes here. Because these are ones that very few people actually get to use. Weird. There we go. That's my wife, by the way. Love that photo. Nope.
You're saying it's time to come out.
Probably. Hey, there it goes. Anybody heard of transaction script? I did misspell 2. You're the second person, number 2, to figure that out. What about domain-driven design? Yeah? A way of isolating domain behavior so that you can modularize different aggregate routes inside a complicated set of domains? What's beyond domain-driven design? When you've got n number of domains interacting across each other. You've got dependencies and structures and those kind of things. That's when you get into these, right? Anybody ever implemented a table data gateway? No? An interface over a class that implements the way you interact with a specific table in a disparate data store. ORMs do this under the covers for you. The object set, when you go, hey, give me a set of T from Entity Framework, or you do a DB set, it's a table data gateway, right? When you say commit to Entity Framework, what's it actually doing? Save changes. When you go, hey, save changes, what's it actually doing? It's closing a unit of work, right? Repository patterns and these kind of things are typically overkill in most systems, right? But in enterprise applications, they're common vernacular. Now, when you spin up a website for a side project, do you automatically install an IOC? Do you automatically install logging, analytics, app insights? Automatically flush out a big security model with like entity mapping modes and all that? Identity mapping modes, sorry. Why not?
Because all I want to do is display static content.
Yeah, all I want to do is update my GitHub thing to, look cool and have a big marquee. Anybody still use marquee? Is it even supported anymore? The HTML tag marquee, where it'll auto-rotate?
I like marquee.
It's GeoCities, y'all.
I like marquee inside of a blink tag.
There you go. Marquee and a blink tag. Absolutely.
That's cool HTML design right there.
It is. Now, here's the fun one. What are some that aren't from the .NET and C# space that we could learn a lot from? Functional space has a lot of good interaction patterns about monitoring state between concurrent operations.
And flows of mesh, basically.
Absolutely. Now here's some other ones. Enterprise application patterns talk about how to solve a problem without dictating exactly what you have to go do. Right? Like the active record pattern. It solves a very clean problem in an easy way. It might not be right for every application. But for large enterprise CRUD applications that are basically some small behaviors over large data stores, it works perfectly. So we're talking about a different class of things. And I'm going to expand upon my analogy from earlier. What if I went to that same contractor that builds those 2-story houses and I asked them to build a 15-story high-rise in Montrose? Think they'd struggle? Right? Think they'd get it done? They might. Massively over cost, massively over budget, massively over schedule, and unsafe. Sound like any projects you might have seen? Now, how many general contractors in Houston build high-rises? General contractors in Houston build high-rises.
50?
Huh?
Not a general contract.
50? Like firms that go and build high-rises that manage it, not actually pay for it, but like manage it, build it, and take care of it.
Not a general contract.
None. These are worldwide. How many high-rises are built in Houston every year? To run a company that does just that, you have to expand massively your scope because the problem spaces are so rare, right? You got a few that work a lot in Dubai, that work sometimes like the Freedom Tower in New York that was this massive high-rise, right? But how many of those buildings downtown were built 20 plus years ago? When's the last time a 70 plus story high-rise was built in Houston?
We don't build up.
We don't build up. Why? Because we don't have that problem.
We
build out because we have space, right? And the reason that that's analogous to enterprise application architecture is very few of us will ever greenfield an enterprise application. It's a true statement. Like how many of us in this room have started literally from zero code on an application north of 5 million lines of code? One. How about 2.5 million? You get to raise your hand at this point.
I didn't say that I was on the initial team.
Oh yeah, you didn't start in ground zero. I actually did the first set of commits.
Yeah, you were.
So here's the thing. If very few of us are ever there, right? Is this a skill set that's common, that's easy to build? No. Now here's the great thing. This is the rarity of what we do. Can you get on-the-job training in being a doctor by sitting inside the room where they're doing heart surgeries? Nope. Guaranteed they will never let you do the heart surgery even though you've seen 30 of them. But as software developers, all the time. We build new surgeons constantly. Because once you've had that aha moment in the Shuha-Ri, that aha moment of, oh wow, I have seen this go well and I have seen this go badly, and this was the difference. You can't go back. Right? I have fought tooth and nail for weeks on end to keep a group of really smart people from making a mistake I made a decade ago because I knew the cost. And they fought tooth and nail for weeks to keep me from falling in the hole they fell in a decade ago because they knew the cost. And you get enough of those folks around a table, and typically it's 4 to 7. You'll end up solving big problems that no one person could do. And the people that coordinate that group, they're doing this. They're putting the smartest possible people they can in a room. They're analyzing tons of integration patterns. And they're coming up with a solution that solves today's problems and a decade from now's problems, as close as they possibly can. Now here's the funny part. The basic patterns for that project that I was talking about with Devlin, the basic patterns of how you solve the problem haven't changed in 4 years. The implementation has changed constantly. We've grown new understanding, we've shifted technology, we've upgraded things, but the basics of interconnected systems with a messaging base between them, doing short, small chunks of work, right? The management of state through a SQL server that allows for transactional commits, and the independent modularization through domain-driven design. Those are those core decisions that we fought over for months. And so far, they've stood the test of time. How can you tell if this is done well? Huh? It stands the test of time. How long it stands is a testament to this problem and how well it was solved. Anybody ever worked with a system that's lived for 20 years and still runs every day in the business? Absolutely. Do you know the developers that worked on those programs? Right? I had the privilege of working with a gentleman, Brian Burris, who wrote a bunch of manufacturing and automation software at Tyson Foods. And one of the things he did was some IBM mainframe work that to this day runs raw receiving in over 100 locations, day in, day out, without fail, without data problems, just works. It's a green screen application. And you know how much motivation they have to go rewrite it? 0. You know how many problems they have with it? 0. You know how many times IBM's tried to get them to rebuild it? Dozens. That's because it solved a hard problem, it solved it well. Now, how many times have we seen an enterprise application that got built and 3 years later got rebuilt? Because it was falling all over itself, couldn't support the growth of the business, and just failed. Right? I have walked into those. I'm a professional firefighter. I get to walk into those all the time. You do too. Those, they missed this one. And typically it's years later. They spent years billing at great bill rates to sail this ship down, excrement river without a form of locomotion. These are the hard ones because the failures are easily apparent and the successes are hidden. But when you finally see that actually deliver well, those are the ones that you put and you go, that's one of the proudest things I worked on in my career. But it requires a lot of hard fights, a lot of convincing other people that the mistakes that have been made in the past won't get made this time if we just make this change. Listening to a lot of decisions and then honoring them. Because here's the thing, it's the remaking of those decisions that typically brings down the system. I have personally worked on a system that has 4 different data access programs, 3 ORMs, and some hand-coded ADO. Because once the decision was made, it wasn't enforced, and it was remade repeatedly. The best enterprise applications can be brought down by inconsistency. It's not consistency for consistency's sake. It's enforcement of a decision because the downfalls of making it again are worse than the fact you made the wrong one and you have to deal with it. Now, how many of us are comfortable with the idea of knowing you made a mistake, but knowing you're not going to fix it? Every day. Because here's the thing, the cost of fixing it might destroy the application.
Yes.
Right? If it's going to cost another $1.5 million to go fix it, the business might just say, I'm done. It might cause it to no longer have an ROI, or it might delay it so far that you lose executive support. When you're talking at these scales, making a bad decision and sticking with it is the hard decision. It's that awareness that software is a means, not an end. And sometimes bad software makes a lot of money. Do you think Brian is really proud of that green screen application? Part of him is. He's proud that something he built 25 years ago, 35 years ago now, sorry, is still running every single day. But he's like, man, it could be so much better if only. But he had the wherewithal not to chase the if only. That's that level of awareness that differentiates an enterprise application architect in the long term from that systems designer that really just wants to build the perfect system. I want the perfect house of cards. The enterprise architect's looking at it and going, yeah, the house of cards has issues, but it'll stand for years. Right? I had to tape this area, I had to super glue this area, but it worked. And you're oftentimes having to dumb down hard problems into simple solutions. You're having to architect for the lowest common denominator. Because you're matching the problem space to the skill sets, and at these scales, the skill sets keep slipping lower and lower. Right? How many times has somebody interacted with a developer, they got brought into a project because they were cheaper, and you go, holy crap! Yeah, that guy's making $14 an hour, which is a good living where they live, but not here. And they're terrible. Now, I'm not saying all of them are. I've met some great developers that work overseas as offshore. But I've also met some really, really terrible ones. Ones that couldn't find good code with 2 hands and a map. But that's who we have to architect for. Because at these scales, you need data entry. Remember at the beginning we talked about the level of evolution to get to technical design was realizing it's not about solving the problem. This is where that flips and it goes, you now have to build an architecture that's going to allow people who only care about solving the one problem to succeed. And that oftentimes makes us unwilling to do it. You'll hear statements like, we hire better developers and this architecture will work. Means it's a bad architecture. We need to lower the bar of success so low we can't help but trip into the end zone. And an enterprise architect is trying to do just that. Oftentimes against the fights from the systems designers that work with them, to the solutions designers and tech leads, and the technical design at the bottom. You get those tech leads that never moved up that awareness chain, and they are frustrated, they're pissed, and they often leave. Because the quality of the code is slipping. We're doing all these things. We're making all these mistakes. And the enterprise application architect is looking at it and going, we're making the business better, and we're adhering to the architectural solution. And so it gets to be this uncomfortable space where you have to start trading the technical nuance at the micro level for the technical solution at the macro level. And a lot of us, myself included, have a hard time with that jump. I constantly fight that jump. But I've met a few people who could make one more step. And by a few, I mean 3. I've only ever met 3 people that can make this jump, and one of them's here in Houston. His name's Curtis Schlock. To true enterprise architecture that is independent of application, that is about systems and platforms and interoperability that will stand for 20 plus years, that will allow for building multiple enterprise applications, multiple systems, multiple solutions by varying skill sets to solve massive problems and stay current so that I don't have to run a green screen app on a Windows XP build that's no longer supported in a closet somewhere to keep production running. Not that that ever happened. Solution architecture is about long-term interoperability. It's about long-term looking to take advantages of technological advancement in the market without the cost of going, oh, we'll just rewrite everything we have. It's looking at all the history and charting a path forward. Looking into a cracked crystal ball and trying to figure it out. Now, what's that actually mean at the tactical level? How important is machine learning to what we're doing right now? Kind of cool, nifty new thing, might pan out. If it pans out, how important is it 5 years from now? Massively important, right? I promised I was going to use a whiteboard. Here we go. So here's the thing. Technological advancement is typically a log curve, right? In which the dotted line is feature parity for current systems, right? Think about the advancement from IBM mainframes and DB2 to .NET. That, on the grand scale of things, happened that quick. Think about the difference between COBOL and what we write today. In the grand scale of time, that quick. Because progress is so slow and almost not evident until you're 90% the way there, emerging technologies, an enterprise architect actually has to look at them critically, watch them mercilessly to figure out which ones are going to jump the chasm and which ones aren't, so that the things are prepared and ready. So what would you do if you were an enterprise architect today to prepare for machine learning, knowing that it may never come true? The promise of machine learning as it changes our business may never happen. You weigh your decision? Delay, absolutely. But there are some decisions that if you don't make them now, you're not going to be ready.
Don't collect that data that you're going to learn from.
Start building a massive storehouse of data. Because either machine learning will solve it, or analytics will solve it, or this will solve it. There's 16, 17 different things that are emerging right now that will take advantage of larger sets of data than we've ever done. And one of those is likely to succeed. So I don't care which one of them it is, as long as I start collecting and architecting massive storehouses of data. Which means I'm going to recommend to a CIO to do what? Start investing in good data warehousing. Because you're going to be able to take advantage of it with one of these things. Yeah?
If that was true, why would people build data lakes?
So data lakes is an interesting thing. It is a no-op answer to this problem.
Well,
do you know which?
To defer the decision.
It is. It's the I don't have the answer and I don't feel confident in any of the options. We're going to have all of them and put them in a place that allows me to use all of them. If you want to use data lake with Mongo and documents, have after it. You want to use data lake with SQL or Oracle, have after it. And so I can choose all the options because I don't know which one is going to long-term be the answer. Data lake is a deferral mechanism, a no-op answer, because enterprise architects didn't know the answers. And they couldn't tell which one was going to succeed of the ones that had jumped the chasm. We've been hearing about object storage or document storage for over 30 years. Object databases existed before SQL. And enterprise architects that have been jumping up and down going, it's the next greatest thing, for 30 years. And we've been wrong for 30 years. We get it wrong as enterprise architects because of this problem. There's no timeline on the bottom of that graph. It might be that we're halfway through that bottom curve for document databases. It might be that we're just at the cusp and it's going to skyrocket. Cosmos is a blending of that, right? Everybody heard about Cosmos? Yeah? In Azure, Cosmos allows you to interconnect relational data and non-relational data and choose the API by which you want to interact with different objects. And Entity Framework is going to support Cosmos so that some objects can be documents, some objects can be relational, and you don't have to care in your application.
So it's nice.
And we're back to that Lotus Notes app. And so,
Well, that's what it was.
And so enterprise architects have to weigh the future by likelihood and make recommendations that will prepare for a ton of different eventualities. When technology is accelerating, when platforms are changing. 5-10 years ago, who could have predicted that .NET was going to go open source multi-platform? None of us. And if you say you could have, you're lying. Right? And so we're having to predict things, or at least make decisions that we know can deal with the majority of eventual outcomes. And you know what happens when you get this one wrong? You put a company out of business.
Unless they're IBM.
You put a company out of business. Right? Anybody ever heard of Friendster? Yeah?
Vaguely.
Yeah? What about MySpace?
Still around.
Still around. It's been sold 4 times. Each time for less. But here's the thing. They got some of this wrong, massively. They made big technological bets on the wrong technologies. And they couldn't easily jump to others. Facebook was originally written in PHP. What's it written in today? Huh? They got some React. They've written their own language in some places. Right? It was originally launched on a relational data store. What's it on now? It's on Polyglot. Right? I mean, you talk about, and I'll have to double check it. I might be getting my social medias mixed up. Right? Because they built, scaled, reevaluated, and made new recommendations, they didn't bet on any single technology to carry them all the way to the finish line. They bet on a median path that would get them there. Right? Alphabet has been doing this, Google's parent company, for a while. Microsoft does this often. They wait until a B player makes the hurdle, and then they acquire them. It's a good plan if you got that much cash. They're letting other companies do their R&D, and the people that are successful in the R&D make a payday. Sounds like a great plan to me. Now they get vilified for it. But here's the thing. Which distributed source control was going to win 8 years ago? Was it Git or Mercurial?
Oh, Git, absolutely.
Mercurial had the biggest user base. Git was an esoteric thing thrown together by Linus on a weekend in a vodka. And it was literally hard to use on purpose.
They were actually both thrown together because of license restrictions.
Git BitKeeper. Yep. So here's the thing. In that world, if you're Microsoft, do you make a big bet on either of them?
Mercurial has a better model.
It did. But Microsoft didn't know who was going to win. They didn't make a big bet either way. They held to the evolution of VSS that became the Visual Studio's TFS source control, and they waited. And when it became evident that Git was the standard, they added Git support, they closed down Codeplex, and they bought GitHub. Yeah.
You didn't hear that?
And so here's the thing. Good enterprise architecture can make a company a boatload of money. Bad enterprise architecture can put you out of business. Right? What about the enterprise architect over at Ashley Madison? huge technology site, made a lot of money, decided to use OpenSSL for security instead of paying a little bit more for a different SSL provider for their application. What ended up happening? They made a hardline bet on the wrong choice, and it dumped them hard, right? These are one of those things that, especially in today's world of increasing cybersecurity issues, increasing data privacy issues, right? We've got entire legal divisions now dedicated to how we manage people's data and those kind of things. Enterprise architecture's job's getting harder, not easier. And you've got things like TOGAF, the Open Groups Architectural Framework, that's saying here's a series of processes by which you can evaluate these things and make good recommendations. And they've got certifications, they've got structures, and it's actually some decent stuff. I disagree with some of their stuff, but some of it's really decent. TOGAF. T-O-G-A-F. Enterprise architecture is continuing to emerge as an absolute need. Right? Most enterprise architects report directly to the CIO, but they are not the CIO because they have to stay deep into the emerging technologies. They can't be responsible for the delivery of applications because they've got to be looking at what an application is going to need to be 4 years from now. Right? These are not the people heading up projects. These are the folks doing R&D, doing proof of concepts, doing test outputs to try and figure out if that thing is truly going to move their business or not. They've got to know the implications if they were to build an enterprise application on that platform, on that technology, on those choices. They've got to know the implications of the systems that may come out of that choice, which means they've got to be good at every other level of this evolution. But then they've also got to be able to disconnect all of that and put it down to dollars and cents. What's the risk to the P&L? What's the risk to the business future of choosing or not choosing? And overall, they've honestly got to be willing to be patient in a world that is telling you to act now because this is the next greatest technology. How many of those folks are feeling bad that they made a big enterprise bet to build applications on AngularJS? Okay, what about Ember.js? Had a bigger user base. Anybody still using it? Maybe a few people. Right? So this is where it becomes, you'll notice that for the last 3 levels of this, we've been talking about soft skills and business. And this is often why the perception is disconnected and in Visio. Because it's an easy way to conceptualize hard problems into boxes and arrows. But a good architect at any one of those levels can drastically change the output of a business. You want to start stepping up that awareness chain, or you're at a level and you're looking at the next one, start looking at the pieces of that disconnect that you don't have. Right? Start reaching out to some of the best architects in Houston. There's not a ton of them. Right? If you're doing solutions design now and you want to get better at systems design, start reaching out in that network and finding folks that have been doing systems design and start learning, right? The design thinking group that meets here, really great for that, right? You want to become an enterprise application architect, either you can sit around and hope another big oil company spends $100 million on an application, or you might have to look at relocating for 4 or 5 years because there's a project like that kicking off somewhere in the world, right? It's the same reason that high-rise companies go all over the world because that's what they specialize in, right? Like massive suspension bridges. There are companies that do that, right? Digging tunnels, like the Channel, right? The subways. There are companies that do just that and they go anywhere in the world to do it. Enterprise application architecture, very similar. Sometimes you may have to go find the projects to do it. I've been lucky. I've gotten kind of thrown into a few of them. But I also ended up getting thrown into a few of them in 4 different states because I was bouncing around and the projects happened to be where I was there. Right? Houston's a good market, but it doesn't always have these. So it depends on where you're looking and what you want to be doing. Make sense? So I've been rambling for a little while. I'm going to give you guys a chance to ask me some questions.
So you say you have design meetings here?
So there's a design thinking group that meets here in Houston. They don't actually meet here. They meet downtown at, what's the surge replacement? Station? They meet at Station. Yep.
So part of the conversation made me think of a very good book, although maybe not enterprise level, but it's called Beautiful Code, where essentially it was just every chapter was an elegant design for a different kind of problem.
Yep.
And really the thing that we gained from the book was that different problems needed completely different solutions. A lot of things that you would consider to be bad design. But for the purpose,
Yep. So I strive for elegance in code. I often miss into clever. Often. But those rare times where you hit elegance, where the problem and the solution meet, and there's no overage, right? You don't miss any part of the problem, and the solution only does that. The places where they meet, and it is so perfectly fit that you end up in elegance, are rare. But when you find those, you open that code and are whelmed. It's not overwhelmed. It's not underwhelmed. It's exactly what you expected and nothing else. Those are rare. And Beautiful Code's a great book. Clean Architecture is another good one. Code Complete is another one. As you evolve, right? So Clean Code will get you technical design. Code Complete will get you solution design. Clean Architecture gets you to systems design. Right? Beautiful Code starts getting into the larger architectural pieces, but they focus a lot on the downscale piece. And so then you get enterprise integration patterns, which is that enterprise applications piece. Right? 6 books that talk about the transitions to those higher levels. What's the book for enterprise architecture? It hasn't been written yet, or at least I'm not aware of it. Somebody figures out how to canonicalize that lesson into a book, whoo, I'm reading that. And I'm buying all my friends that.
There's a Pluralsight course.
Huh?
There's a Pluralsight course that talks about Zap and all of that, and just basically what enterprise architecture is.
Yeah.
It doesn't go into very nitty-gritty of them, but like they talk about
Good introductory. Yeah. And so I'm waiting for the book that is like enterprise integration patterns. Anybody ever read the EIP book? Yeah. That is the Bible of building massive enterprise applications. Because it walks through the difference between channels and queues and the difference between the different patterns for interaction styles between pieces of systems. And it will walk you through why, when, how, and where each of those is applicable and how badly it goes when you use the wrong one.
that book, I remember my experience when I read it. That was, you would hit upon one of those solutions and you'd be like, oh man, that's exactly what I was looking for. Like, in so many situations where you say, wow, it's the answer, right? Literally,
Yeah.
it has all
Here's the problem.
you were looking for.
Here's the answer.
Yes. And it's like, it's perfect. It was the solution, you just didn't know it existed.
Yep.
It was a pattern that had been thought of a long time ago.
And so here's the thing, that book has something like 60 of those, where it's like, it describes in depth a problem that very few people will ever have. And then here's a perfectly elegant solution to it. And it talks about things that were like research papers that published actor patterns, right? And has this, oh, you want an actor pattern that carries state forward and gives you a cancelable response in return so you can do this kind of asynchronous interaction. Like, sure, exactly. We stumbled into one of these on a project, and it was exactly the right answer for that problem. It's like, yes, I stumbled into it on a white paper that was pulled off of a college BBS. I send it out, I'm like, I think this exactly solves it. And it was Asynchronous Actor Patterns was the name of the white paper. It was some guy's doctoral thesis. And it was perfect. Turns out, by the way, it's in EIP. Enterprise integration patterns. It's like the 40-something one. Yeah.
So,
Nope.
as a lead or as a contributor to the team, when you hear these kind of things that we are going to destroy the code quality to deliver, there is a common thing across the team that goes with it. Deliver it, then make it fast, then make it right. And it never reaches the third phase.
So here's the funny part. Deliver it and it's fast, it is right.
No, it takes sacrifices on the terms of, like you said, like the readability, the maintainability, the extensibility.
So
it solves.
I'm going to talk for a moment about finance. Anybody in here have a credit card or ever had debt of any kind? Yes? Right? So I have a house. I got a good mortgage. Is it good debt or bad debt?
Good debt, because it's an appreciating asset.
Right? I've got an appreciating asset. I've got a low interest loan on it. I believe, personally, all debt is bad, but it's not the worst debt I could take. Right? It's not a title loan. It's not a cash advance on my paycheck.
It's an appreciating asset, it's good debt.
Right? And so, largely, the financial institutions will tell you it's good debt. You make the same choices as a systems architect, a solutions architect, and as a tech lead. Am I taking on good debt or bad debt?
Sometimes the payday loan is the right answer.
Sometimes it is. By the way, if getting to production by a certain date means the company goes bankrupt or not, I don't care what I have to do. I'll hard code production connection strings in that thing to get it done.
But you have to have a plan to get out of that debt.
Absolutely. You've got to go into the debt open-eyed. Now here's the other piece, and it's one of those that's kind of way out in the weeds. If I told you today that you had to write a C# compiler by next Friday, or the world was going to end, what would be the first thing you did?
This is not
All of C#.
Huh?
All of C#.
You have to support every functional piece of C#7 perfectly by the end of next week, or the world ends.
Go to the mono and download Devlin shit.
Bingo.
Let's assume for a moment you have to code it from scratch.
Go find the best people you know and work with.
Go find the best people you can possibly find and solve the problem. Do you care if you would your first demand be a fast machine, a good keyboard, soda, and a standing desk? No.
I wouldn't want the standing desk.
Here's the thing. Your first demand is, I need the best compiler writers on earth. Right here.
And somebody's coded it before.
Right? I want Anders sitting in my desk. Right? That's the difference. You, as an architect, you honestly decide what's important. And as a tech lead, it's the smaller scale. Is it important? Is it not? There is some debt you're going to take on that it's important, but the consequences of failure are so drastically overblown that it's not that important, right? The consequences of failure in this example are the world ends. Do you think we're going to cut corners on that? You're damn right we are. Think we're going to work a lot of death march hours? Damn right we are, right? We might even be sniffing coke to get this thing done, but we're going to get it done, right? Because you're taking on all those problems to avoid an even worse problem later. Technical debt is the same way. And the architect's job is to set the guidelines that define good debt and bad debt. A tech lead's job is to minimize bad debt. That's it.
So, the thing I've run across before is identify a technical solution that will solve a large part of the business domain problem. Say for example, message buses or a message queue. But there's not the skill set to manage that kind of system doesn't exist. So, I mean, it seems like the people are the problem more than the technology.
So,
most of the decisions that have to be made.
Keep in mind, we switched to people problems at level 2. Right above tech design, right? When we got into solution design, it was matching skill sets to people and to problems, right? And technical ability to deliver was no longer the primary driving factor. Yes, it is a people problem. Why does JP Morgan use Java for what they do? There are 6 or 7 better options. Better by every technical measure. Why do they use Java? There it is. Because to the business, replaceability for developers and the ability to scale up and down easily in a market that is, pretty prevalent with good talent is a bigger problem to solve than a little bit of technical advantage.
Now, is this all cost of ownership?
So it's less about TCO or total cost of ownership than it is about, let's see if I can properly relay this. Most CIOs aren't in the boardroom, right? A CEO doesn't care what language it's built in. Zuckerberg does not care what Facebook is built on anymore. He cares that it solves a problem, that it's built well, and that it doesn't endanger the business. The last one is the important one. Does not endanger the business. And picking an esoteric but better technical solution would endanger JP Morgan's business. Because let's say that quits being supported, or those developers just decide to go off and do React over Node because it's cooler. And now they have this massive system that they have to spend huge amounts of money pumping into it to build, train, and maintain developers. It's the COBOL problem. How many people work actively in COBOL today?
There's still some.
There's still some. They're crazy expensive. Crazy expensive and rare because there aren't that many of them that can write their own ticket, which endangers the businesses that are latched on revenue stream in hand to a COBOL application. Those businesses are in danger, right?
I should go back to writing COBOL.
And so it's that thing of endangers the business is the measure that those decisions get made on at that level.
I'm going back to relating this to my question that I asked earlier. Can you give some examples of good debt?
Sure. So,
like I see domain classes written with parameter-less constructors, and all of them are public.
Sure.
Properties are public.
So let's say that I'm working on an application that I just stepped into, and I want to add dependency injection because it solves a problem, but I don't have time to go extract every constructor and truly do dependency inversion, right? So I choose to use property injection. I make all the properties of the dependencies public. That's a design mistake that I'm intentionally opting into because the benefit outweighs the mistake, with the hope that eventually we go to constructor injection. But guess what? If we never go, we're still better off. It's good debt.
It's semi-good design.
It's better than.
We are talking about progress, not perfection, because perfect software never makes it to production. Perfect changes every week.
I guess that what you're trying to say is that the distinction between a bad architect and a good architect is to be able to realize when to take it.
Absolutely. It's CMMI level 5.
Yes.
When to break your own rules. Right? Now, should a tech lead ever make that call? The technical designer. No. I never want a tech lead making a call at scale to differ from a design choice. I want a conversation.
The tech lead should be enforcing the rules that you set.
Yep. And if they want to differ, there is a path to differ, but it is not their decision. Right? This is, and I now run a business and run sales, so I run into this all the time. You have two kinds of people involved in sales. Those empowered to say no, which are many. And those empowered to say yes and sign the check. There's only one of those. Same thing in architecture. A tech lead is empowered to reject a code review because it violates the architecture. They are not empowered, however, to accept a code review that violates the architecture.
How do you get that vision up and down the chain so that people aren't?
You communicate the enterprise design patterns by which the application is built. You establish code reviews for the tech leads, and you establish design reviews for the systems and solution designers, and the enterprise architects do spot reviews on completion. And when they find a problem, they don't go to the developer that did it. They go, hey, systems design guy, one of your systems is out of whack. Go fix it. They're looking at different scales of problems. It's the same way that the military can effectively get into and out of countries with tons, I mean, literally physical tons of equipment and not lose a bunch of it. We don't actually lose a bunch. We lose a little bit. We don't lose a bunch. They have standard operating procedures, and they have commander's guidance. The standard operating procedures are the enterprise design patterns that we have chosen to apply to this specific area. And the commander's guidance is when you feel these don't apply, here are the rules. And that can go all the way down to a tech lead. Here's your definition of done. And if you feel this is inappropriate, it's a conversation with the systems designer. Absolutely. There's a chain of command and there are rules with just about everything in our lives, right? If I want to go spend a lot of money, there's a chain of command. It goes straight to my wife, and there are rules. The answer is no. And I obey that chain of command and those rules, and when I don't, I get in trouble. She's going to love that clip, by the way. Make sense? It's a hard thing because how many tech leads value their autonomy? So you have to do it in such a way that you don't destroy the motivation and autonomy of those tech leads, which means you have to give them vision, which means architecture is less about technical decisions than it is about leadership.
So something interesting that's is when you design a system for a certain level of developer, and then for whatever reason you're presented with a different level of developer later on, right?
Mm-hmm.
And you realize that your patterns just aren't similar.
Yep.
For example, a lot of the stuff that you do on our project, active record pattern, would probably be the way to go.
Yep. And it would be far simpler.
It's a very simple pattern for the developer to follow, right? But that's not what we do.
Nope.
So, it's an example of one of those decisions.
And now that your assumptions have changed, you have to evaluate. Is the cost of putting that pattern in place on top of our other patterns worth it or not, right? And so what will most likely happen, and keep in mind I have a little knowledge of what he's talking about, what will most likely happen is that somebody, probably a level 4 or 5 dev, by the way, if you want the levels, oh, that didn't work.
She's level 5.
She is way beyond level 5. She puts up with this, right? 1, 2, 3, 4, 5, right? Probably some level 4 or 5 folks are going to go through, look at the pattern, solve the problem, and build the adapter. That is, by the way, one of those terribly crappy pieces of code that you hope will never, ever get touched again. To take active record sets and turn them into the other architecture, because teaching a massive group of underskilled developers hard patterns isn't worth it. I have moved one place from TFS to Git, trained dozens of developers, what rebase meant, what git flow meant. I was one of the few people that got to rewrite history when they screwed up. And I will tell you, I will never do it again. We will simply hire the right people. Because for that size, that scale, and that skill set, a centralized source control is the right answer. I can put gated builds and I can enforce dictatorial rules on low-skill developers. It's the right answer for that problem, Even though most of the people in this room are going, oh, because it works to solve the problem at hand, even though it makes us feel like, I'm working on something 10 years old.
But
So,
you're saying with Git, I can't put in commit hooks and stop people from doing something that do that.
you can auto roll back commits, and you can write PowerShell locally that will go do those
This is a
things.
very real problem.
It really is.
Yes.
But I will never do it again. I learned that lesson the hard way. I don't know how many millions of dollars that decision spent, but it was millions, not thousands.
That wasn't the microwave in the server room, though.
Nope, wasn't the microwave in the server room. That was cheaper. That one only cost a few $100,000. So I had a former coworker, former because I left, not because he got fired, who blew up an ESX server by putting his microwave on top of it, old crank style one, in the server room with the Halon system, threw his lunch in there with the fork in it. It exploded, nuked the power unit, and melted a $280,000 ESX host. Yeah.
Was it on TV though?
Still employed. They built him an office and bought him a new microwave.
Awesome.
Very, very high.
To move him out of the server room because he put his desk in a server room with a halon system. Halon, by the way, is a dust particulate that binds to oxygen. If inhaled, you suffocate. And his desk was in there. The only reason he's alive is because he threw his lunch in there and then walked out the door to go do something else. They built him an office, replaced the server, bought him a new microwave. And that was a cheaper decision than moving that project from TFS to Git. I will never know the cost of that decision because the people on that are still feeling the pain today. That's why enterprise architectures and above, you want to get as many people in the room with as many scars as possible so you don't walk into those doors again. So I'm sorry I ran a little over. I like to talk. Hope you noticed. I'm going to stick around for a little bit if anybody has questions, wants to chat and go, oh, that's nothing. I got this one time. This guy did something really stupid. I love hearing those. But thank you all for coming out. Please feel free to take a soda for the road.
Thank you for joining us for the June 2018 meeting of the Houston.net Users Group. Our next meeting will be on July 12th at the Improving Houston office at 10111 Richmond Avenue. If you happen to be in the Houston area, then or on any second Thursday, we'd love for you to join us.